Imagine discovering that one of the ocean's most prized delicacies, selling for up to $400 per kilogram in luxury restaurants, is now being cultivated in massive aquaculture operations housing over 20 million individual creatures. These ancient sea snails known as abalones have been transformed from a nearly extinct wild species into one of the most profitable forms of marine farming, generating over $2 billion annually in global markets. What makes these single-shelled mollusks so incredibly valuable that commercial divers once risked their lives harvesting them from dangerous underwater cliffs? How do modern farmers raise millions of these slow-growing creatures that can take up to 7 years to reach market size? And what sophisticated industrial processes transform these exotic shellfish into the luxury cuisine products served in the world's most exclusive dining establishments? Welcome to AgriCraft, where we explore the most fascinating and profitable agricultural enterprises from around the globe. Today we're diving deep into the exclusive world of abalone farming, a highly specialized form of aquaculture that combines traditional knowledge with cutting-edge agriculture technology. From the temperature-controlled hatcheries where microscopic abalone larvae begin their journey to the precision processing plants where mature abalones are prepared for luxury markets worldwide, all will be revealed in this video. The story of abalone begins millions of years ago, when these remarkable creatures first evolved their distinctive single spiral shells and powerful muscular feet. Archaeological evidence shows that coastal peoples have been harvesting abalones for over 7,000 years, with massive shell middens along the California, Australia, and South Africa coastlines documenting the importance of these mollusks in ancient diets. Wild abalone populations once thrived in rocky intertidal zones and kelp forests around the world, with some species growing shells over 12 inches in diameter. These massive gastropods played crucial ecological roles, grazing on algae and maintaining the delicate balance of marine ecosystems while providing protein for coastal communities from Native American tribes to Aboriginal Australians. The transformation of abalone from abundant wild resource to critically endangered species happened with shocking speed in the 20th century. Commercial diving operations, pollution, disease outbreaks, and climate change devastated wild populations by over 90% in many regions. California's white abalone became so rare that it was listed as the first marine invertebrate under the Endangered Species Act. The crisis in wild abalone populations sparked intensive research into artificial cultivation that began in the 1960s in Japan and Australia. Early pioneers faced enormous challenges since abalone reproduction and larval development proved far more complex than other commercially farmed shellfish. These ancient creatures required specific algae diets, precise water conditions, and incredibly patient management throughout their slow growth cycles. The breakthrough came in the 1980s when researchers finally cracked the code of abalone hatchery production, developing techniques to reliably spawn adults, raise larvae, and grow juveniles to marketable sizes in controlled environments. This scientific achievement launched a global aquaculture industry that now produces over 90% of all abalones consumed worldwide. Today, abalone farming operations exist across multiple continents with major production centers in China, Australia, South Africa, Chile, and increasingly in the United States. China dominates global production, operating massive facilities that house millions of abalones in sophisticated recirculating systems. These industrial-scale operations represent some of the most advanced aquaculture technology in the world. The economic transformation has been remarkable. What was once harvested by individual divers risking their lives in dangerous waters has become a controlled agricultural enterprise supporting thousands of jobs. Modern abalone farms can produce consistent harvests while contributing to conservation efforts that are slowly rebuilding wild populations through habitat restoration and breeding programs. The complexity of abalone farming extends far beyond typical shellfish aquaculture. These ancient mollusks are among the most challenging marine species to cultivate commercially, requiring specialized facilities, expert management, and extraordinary patience since most species grow very slowly compared to other farmed seafood. Successful abalone farming begins with selecting appropriate species for local environmental conditions and target markets. Red abalone, favored for their large size and excellent meat quality, can take 6 to 8 years to reach harvest size but command premium prices. Green lip abalone mature faster at 4 to 5 years while producing smaller but still valuable products for restaurant markets. The foundation of any successful abalone operation lies in the hatchery, where the complex process of reproduction and early larval development takes place. Professional abalone hatcheries maintain carefully selected broodstock populations of proven genetics for growth rates, survival, and meat quality characteristics. Broodstock management involves conditioning mature abalones through precise manipulation of water temperature, photoperiod, and nutrition to induce spawning behavior. Unlike many marine species that spawn naturally in response to seasonal cues, captive abalones often require artificial conditioning that can take several months to achieve optimal reproductive readiness. The spawning process itself requires expert timing and environmental control. Mature females can release millions of eggs during a single spawning event, while males simultaneously release sperm clouds that fertilize the eggs in the water column. Hatchery specialists must coordinate this process to achieve maximum fertilization rates while maintaining optimal water quality. Fertilized abalone eggs are incredibly tiny and develop into free-swimming larvae within hours of fertilization. These microscopic veliger larvae drift in the water column for several days before settling and metamorphosing into juvenile abalones. The survival rate during this critical period can be extremely low, making expert management essential for commercial success. Larval rearing systems maintain precise water quality parameters including temperature, salinity, dissolved oxygen, and pH within narrow ranges that optimize survival and development. Professional hatcheries use sophisticated filtration and monitoring systems to maintain stable conditions while providing appropriate algae food sources for developing larvae. The settlement process represents one of the most critical stages in abalone cultivation. Larvae must encounter specific settlement cues including appropriate substrate textures and chemical signals that trigger metamorphosis from swimming larvae into bottom-dwelling juveniles. Hatchery operators use specially prepared settlement plates designed to maximize settlement success rates. Newly settled juvenile abalones are microscopic and incredibly vulnerable to environmental stress, predation, and disease. They require specially formulated diets of microalgae and later transition to macroalgae as they grow larger. The mortality rate during early juvenile stages can exceed 90% without expert care and optimal conditions. The grow-out phase begins when juvenile abalones reach several millimeters in length and can be transferred to larger cultivation systems. This stage requires massive infrastructure investments since abalones need years of careful tending before reaching marketable sizes. Modern abalone farms utilize various cultivation systems including land-based tanks, sea-based cages, and integrated recirculating aquaculture systems. Land-based operations offer maximum environmental control but require significant energy inputs for pumping, heating, and water treatment. Sea-based systems leverage natural ocean conditions but face challenges from storms, predators, and water quality fluctuations. Water quality management in abalone farming demands constant vigilance since these sensitive mollusks are extremely susceptible to ammonia, hydrogen sulfide, and other metabolic waste products. Advanced filtration systems including biological filters, protein skimmers, and ozone treatment work continuously to maintain optimal water chemistry. Temperature control represents one of the most critical and expensive aspects of abalone cultivation. Most commercial species prefer water temperatures between 15 and 20 degrees Celsius, requiring sophisticated heating and cooling systems that can represent 40 to 50% of total operating costs in some climates. Algae production for abalone feed often requires dedicated cultivation systems that can produce tons of fresh kelp, sea lettuce, and other macroalgae annually. Some operations integrate seaweed farming with abalone production, creating symbiotic systems where nutrient-rich abalone waste fertilizes algae growth while algae harvest provides fresh food for the mollusks. Feeding protocols involve providing fresh algae multiple times daily, while carefully monitoring consumption rates and removing uneaten feed that could decompose and degrade water quality. Advanced farms use automated feeding systems and underwater cameras to optimize feeding schedules and minimize waste. Growth monitoring requires regular sampling and measuring of abalone populations to track development and identify health issues. Professional operations maintain detailed records of growth rates, mortality, and environmental conditions that help optimize production efficiency and predict harvest timing. Disease prevention in abalone farming relies on maintaining optimal environmental conditions, implementing strict biosecurity measures, and working with specialized aquaculture veterinarians. Abalones can be susceptible to bacterial infections, viral diseases, and parasitic organisms that can devastate entire populations without proper management. The maturation process varies significantly by species and environmental conditions. Fast-growing species may reach market size of 8 to 10 centimeters in 4 to 5 years, while premium species can require 6 to 8 years to achieve the larger sizes preferred in luxury markets. Harvesting mature abalones requires careful timing to ensure optimal meat quality and maximize economic returns. Unlike other shellfish that can be harvested year-round, abalone harvesting often follows seasonal patterns that coincide with peak meat condition and market demand for luxury seafood products. The harvesting process begins with draining cultivation tanks or bringing in sea cages to access the mature abalones. Each individual must be carefully examined to determine size and quality before deciding whether to harvest or return for additional growth. This sorting process requires experienced workers who can quickly assess market readiness. Manual harvesting remains the standard practice in most abalone operations, since these valuable creatures require gentle handling to prevent shell damage and stress. Automated systems have been developed for some operations, but most farmers prefer hand selection to ensure optimal quality and minimize damage to premium products. Quality assessment during harvesting focuses on shell size, meat condition, and overall health status. Premium-grade abalones feature intact shells, firm meat texture, and uniform coloration that meet specific market requirements. Any specimens showing signs of stress, disease, or poor condition are diverted to lower-value markets or rejected entirely. Live transportation from farm to processing plant requires sophisticated life support systems that maintain optimal water quality during transit. Abalones are extremely sensitive to handling stress and water quality changes, making professional transport equipment essential for preserving product quality and maximizing survival rates. The volume of abalones harvested during peak seasons can be substantial for large operations. Major farms may process several tons of live abalones weekly during harvest periods, requiring coordination between harvesting teams, transportation logistics, and processing plant capacity to handle the continuous flow of live product. Processing operations also coordinate with luxury restaurant chains and specialty seafood distributors to ensure optimal timing between harvest and delivery. Fresh abalone commands the highest prices but has extremely limited shelf life, making logistics coordination critical for maximizing economic returns. The transformation of live abalones into luxury cuisine products occurs in specialized processing plants that maintain the highest standards of food safety while preserving the delicate characteristics that make these mollusks so prized by discriminating consumers. Initial processing begins with receiving live abalones and conducting thorough quality inspection to verify size, condition, and species identification. Trained technicians evaluate each specimen using standardized grading criteria that determine final product categories and pricing structures. The preparation process starts with careful removal of abalones from their shells using specialized tools designed to minimize damage to the valuable meat. This shucking operation requires skilled workers since the powerful muscular foot must be separated from the shell without tearing or damaging the meat that represents the primary commercial product. Cleaning procedures involve removing the digestive organs and other non-edible portions while preserving the prized adductor muscle that constitutes the main edible portion. This process requires precision since any contamination from digestive contents can affect flavor and food safety of the finished product. Advanced processing plants utilize stainless steel equipment and temperature-controlled environments that maintain optimal conditions throughout the preparation process. Industrial machines designed specifically for shellfish processing help standardize cutting and preparation while maintaining the handcrafted quality demanded by luxury consumers. Quality control procedures include multiple inspection points where trained specialists evaluate meat, color, texture, size consistency, and overall appearance. Laboratory testing verifies microbiological safety and ensures compliance with stringent food safety standards required for international export markets. Grading systems classify processed abalone meat into premium categories based on size, color, texture, and defect levels. The highest grades command exceptional prices in luxury restaurant markets, while lower grades may be used for specialty food products or alternative market segments. Some processing operations include value-added preparations such as slicing, tenderizing, and portioning for specific restaurant applications. These services require additional equipment and expertise but can significantly increase the value of the final products delivered to culinary professionals. Sterilization and packaging procedures ensure long-term product safety while maintaining the delicate flavors and textures that characterize premium abalone products. Advanced packaging systems use modified atmosphere technology and precise temperature control to extend shelf life without compromising quality. Processing plants also generate valuable byproducts including abalone shells that are processed into decorative items, calcium supplements, and traditional medicine ingredients. The shell's iridescent inner surfaces make them valuable for jewelry, buttons, and artistic applications that provide additional revenue streams. The packaging stage transforms processed abalone into retail-ready luxury products that preserve quality during distribution while communicating the premium nature of the product to discerning consumers. Abalone packaging requires specialized materials and techniques that protect these high-value products throughout global distribution networks. Premium abalone packaging utilizes food-grade materials that maintain product freshness while preventing contamination and physical damage. Individual vacuum-sealed packages preserve meat texture and prevent freezer burn during frozen storage while allowing consumers to clearly see product quality. Automated packaging systems precisely portion abalone products into standardized weights and package formats that meet specific customer requirements. These systems maintain strict hygiene standards while ensuring consistent presentation and portion control for restaurant and retail applications. Labeling systems provide comprehensive product information including species identification, harvest location, processing date, handling instructions, and nutritional information. Export products require additional labeling compliance with international regulations and often include multiple languages for global distribution networks. Cold storage facilities maintain precise temperature control throughout the packaging and distribution process. Fresh abalone products require temperatures just above freezing, while frozen products are stored at -18 degrees Celsius to maintain optimal quality during extended storage periods. Advanced packaging operations include modified atmosphere systems that replace air in packages with gas mixtures that extend shelf life and maintain product quality. These systems use nitrogen and carbon dioxide blends that prevent oxidation while preserving natural colors and flavors. Distribution logistics for abalone products involve sophisticated cold chain management systems that maintain optimal temperatures from processing plant to final consumer. Temperature monitoring systems provide continuous tracking of product conditions throughout international shipping routes. The global distribution network for premium abalone includes high-end restaurants, specialty seafood retailers, luxury hotels, and increasingly sophisticated online platforms that cater to affluent consumers seeking exotic culinary experiences. Major export markets include Japan, Hong Kong, Singapore, and growing luxury markets in North America and Europe. International shipping requirements include extensive documentation for customs clearance, health certificates from government inspection agencies, and compliance with CITES regulations where applicable. Processing facilities maintain certifications for multiple international markets to serve diverse global customers. Domestic distribution channels serve both food service and retail markets with different packaging formats optimized for each application. Restaurant packaging emphasizes portion control and preparation convenience, while retail packaging focuses on consumer appeal and cooking instructions. Storage and inventory management systems track product age and ensure proper rotation of highly perishable inventory. Computerized systems monitor storage conditions and provide alerts for any temperature deviations or other factors that might compromise product quality during distribution. The abalone farming industry generates several valuable byproducts that contribute to overall operation profitability and environmental sustainability. Abalone shells represent the most significant byproduct, with their iridescent nacre interior making them valuable for decorative applications, jewelry manufacturing, and traditional cultural items. Processed abalone shells are ground into calcium-rich supplements used in both human nutrition and animal feed applications. The high calcium carbonate content makes shell meal valuable for poultry farming and other agricultural applications that require calcium supplementation. Traditional medicine markets, particularly in Asian countries, value abalone shells for various therapeutic applications. These specialized markets often pay premium prices for shells from specific species or regions, creating additional revenue opportunities for processing operations. From a culinary perspective, abalone preparation requires specialized techniques that showcase the unique texture and subtle flavors of this premium shellfish. Traditional preparation methods include tenderizing through careful pounding, slow braising in flavorful broths, and precision slicing for sashimi-style presentations. Modern culinary applications include innovative preparations by celebrity chefs who feature abalone in fusion cuisine that combines traditional Asian techniques with contemporary Western cooking methods. These high-profile applications help maintain strong demand in luxury restaurant markets worldwide. Nutritional analysis reveals that abalone provides exceptional protein quality, along with significant amounts of essential minerals including iron, zinc, and selenium. The meat is naturally low in fat while providing complete amino acid profiles that support optimal human nutrition. The environmental impact of modern abalone farming represents a significant improvement over historical wild harvesting practices that devastated natural populations. Closed-system aquaculture prevents genetic contamination of remaining wild stocks while producing consistent supplies without impacting sensitive marine ecosystems. Sustainability efforts in abalone farming include habitat restoration projects that rebuild kelp forests and rocky reef environments essential for wild abalone recovery. Many commercial operations participate in research programs that study abalone ecology and develop improved cultivation techniques. Water recycling systems in modern abalone farms minimize environmental impact while reducing operational costs. Advanced biological treatment systems clean and reuse water multiple times, dramatically reducing freshwater consumption and eliminating discharge of nutrient-rich wastewater. Integrated multi-trophic aquaculture systems combine abalone farming with seaweed cultivation and other marine species to create balanced ecosystems that maximize resource efficiency while minimizing environmental impact. These innovative systems represent the future of sustainable marine farming. Energy efficiency improvements in abalone farming include renewable energy systems, heat recovery equipment, and automated management systems that optimize energy consumption. Solar panels and wind generators help reduce the carbon footprint while improving economic sustainability for farming operations. From the sophisticated hatcheries where microscopic abalone larvae begin their multi-year journey to the precision processing plants where mature specimens are transformed into luxury culinary products, we've witnessed one of aquaculture's most challenging and rewarding enterprises. This industry represents the successful transformation of a nearly extinct wild resource into a thriving, sustainable farming system. The journey from larval settlement to finished abalone products demonstrates the extraordinary patience and expertise required for ultra-premium aquaculture operations. Unlike conventional farming with predictable seasonal cycles, abalone cultivation demands years of careful stewardship before farmers realize returns on their substantial investments. The industrial scale of modern abalone farming showcases how traditional luxury foods can be sustainably produced using advanced agriculture technology. From automated monitoring systems that maintain optimal growing conditions for millions of mollusks to precision processing equipment that prepares products for global luxury markets, this industry exemplifies the marriage of technology and tradition. What makes abalone farming particularly remarkable is its dual role in conservation and commerce. Every farmed abalone reduces pressure on critically endangered wild populations while contributing to research and habitat restoration efforts that may eventually restore these ancient creatures to their natural ecosystems. The sophistication required throughout the abalone farming process, from genetic selection of broodstock to final packaging for international distribution, demonstrates the complexity of modern specialty aquaculture. This industry proves how agricultural entrepreneurs can create highly profitable enterprises by focusing on premium products that justify substantial long-term investments. Thank you for joining us on this fascinating exploration of abalone farming and luxury seafood production. If you found this deep dive into exotic aquaculture as captivating as we did, please give this video a thumbs up and subscribe to AgriCraft for more comprehensive looks at the world's most unique and profitable agricultural enterprises. Leave a comment below if you'd like to see more luxury food production content, or if you have questions about specialized aquaculture practices we covered today. Until next time, keep exploring the incredible innovation and diversity in modern agriculture and aquaculture.